Welcome to this video guide for use and development of Marketsense. To cover use and development, let's first look at what it's for. Marketsense is a computer program for investigating use of the inherent pattern recognition of the human brain to predict future asset value. Now, this may seem like a step backward, since the principal trend lately has been to replace the brain with an artificial equivalent, and since market prediction via the brain is already done by human traders who watch and analyze performance graphs. However, Marketsense seeks to explore other senses. So far, I've been working with hearing, both because it's an easy sense to interface with, virtually all computers will have speakers for audio playback, and because it has some interesting properties to be leveraged. For example, consider the relativity of hearing. Humans are naturally able to identify the ratio between sound frequencies in relation to each other. But any individual frequency is supremely difficult to identify on its own. In music terminology, you can much more easily identify an interval than a specific note. An interval is the distance, or more accurately, the ratio between notes. A chord is a stack of intervals, and a melody is a sequence of intervals. The relativity of hearing is why you can identify different transpositions of a melody as the same melody. They start on different notes, but the sequence of intervals or ratios remains the same. Sight, on the other hand, is primarily absolute. Colors are analogous to pitches because they are light frequencies, but unlike with hearing, you can identify them absolutely. This is why you know the names of different colors and can recognize them. The absoluteness versus relativity between sight and hearing in terms of light and sound frequency is something in particular that I've focused on with Marketsense because of how similar a melody can be to a historical market price graph. So that's exactly what has been implemented in Marketsense, a way to map market data to sound, and some tools for training against these sounds to try predicting how much an asset price will move up or down. Let's see how to use it. Visiting the GitHub page and going to Releases, I see a distributable version to download, which will require Java 8 to be installed on your computer to run. In my case, I have multiple versions of Java installed, so I need to select a specific one to run it. In the future, perhaps there will be properly bundled versions of this jar file, with the Java runtime optionally included for easier execution on different operating systems. Anyway, for now, I download this runnable jar and run it. The first view I see is the login form, which has a list of accounts that exist already and a username field. These accounts are stored locally to my computer, as is all data generated by Marketsense. If I type a new username, a new account is created, and typing an existing username will select an existing account. Once I've selected an account, we are taken to the dashboard, which will have information for the account and a form for starting a new training session. Here I can pick the security symbol, width of each trade bar, bars per sample, how many months to use is the population for sampling, and the number of samples. Below is also an option to save generated sounds to files for listening later, which will be stored next to the jar in a folder that I'll show in a moment. When I'm ready to begin the training session, I hit the train button. The first time I run Marketsense, I'll need to provide an API key for fetching market data. Marketsense uses 12 data, so I can follow the link to create a free key, paste it here, and then it should be good to go. Here's the heart of the project as of now, where we actually get to hear some market data. This training session will be a set of random samples taken from the past 5 months. The sample in this case has closed prices for CNC, and I need to guess how the price will move next, up or down. Since the exact formulas for what up and down will mean could change, and to simplify the task, I've converted that to a decision between red to the left and green to the right. So I listen. I can listen as many times as I want, and then I guess. Now that I've guessed, I can compare to what actually happened and see what color the movement corresponds to. Note that since I've enabled saving sounds to files, I can find them in the Sounds folder, and they currently have a bit of info about the market data sample in the file name. And I move on to another. Listen, guess what happens? Listen, guess what happens? And again, and again, until I finish the session. Now that I've finished a training session, I can see a brief summary in my session history. The goal of this game would be for me to improve my accuracy as close as possible to 100%, to tune my market sense, in other words. I don't have yet a view for then using live market data, but that's a feature to be implemented soon, so that you can hear what the latest data for a security sounds like and be able to act on it by buying and selling. At this point, I've mentioned essentially everything that you can do with Marketsense so far. If you'd like to help develop Marketsense or use certain components in a different project, or are just curious about the technical side, it's open source with partial documentation, but I'll additionally cover some of those details here. The project is structured to have source files in 3 locations: source, the Marketsense package, 12 data client java/source, the market data API client package and Git submodule, and tempfx logger/source, a logging package and another Git submodule. Within the Marketsense package, I've also put all non-code files in resources, and then grouped utilities into a subpackage and Java Persistence API compatible classes into another subpackage. Marketsense uses the Java Persistence API, or JPA, for maintaining a connection between a local database and the Marketsense application. This is a library used to define conversions between Java objects and corresponding SQL tables. I'm new to JPA and the intricacies, so forgive any misconceptions, but what I think I can explain with the current configuration is that meta-inf/persistence.xml describes my config for Hibernate, the chosen JPA implementation, to create, access, and maintain the local H2 database. I'll be leaving links to these tools in the description. To demonstrate the database, I'll show how to use the H2 console web server tool to access it when Marketsense is not running. When developing with Maven, the H2 dependency containing the database server is stored in the home.m2 path on my laptop, so I have an example shell script to run it in the Marketsense bin folder. The password's just password, and once I've connected, I have a convenient database client here for viewing structure and playing with the contained data. Also note that the database file, as per the default config, will be located in your home directory as marketsense.mv.db. The other place for persistent storage is the config.properties file in the Marketsense resources package. This will be where the program reads in the 12 data API key, for example. To build and run Marketsense, the program will create a copy with the proper name if it doesn't already exist. Since the program needs to be distributable in a runnable jar file, and any files within the jar file are read-only, some resource files, like the config properties file, need to be copied to a writable location. This will be in a sibling resources directory. If being compiled to run within an IDE, that should be next to the folder with bytecode files. If run from a jar, that will be next to the jar file. Let's take a look at how market data is converted to sound. First, we take our sequence of trade bars that we pulled from the database and convert it to raw numbers. Currently, I'm just using close prices. I then feed those raw values to the Marketsense, which will normalize them to a 0 to 1 range, and depending on the desired sound quality and playback duration, will allocate a byte buffer of the correct size. Next, we move on to designing the actual sound wave. I focus on 3 components here: volume, which is wave amplitude; pitches or tones or notes within the sound that can be called the melody, which is a sequence of frequencies in the wave; and timbre or voicing, which is the shape of the wave. The amplitude is just kept uniform for all samples as of now. The mapping of price to melody is pretty intuitive here, choosing a frequency between a lowest and highest for each normalized price, each price therefore corresponding to a single pitch. Deciding how to manipulate timbre was more of a challenge, but my current approach is to use each normalized price as a harmonic over the current bass tone and compose them all on top of the original sine wave at the same time. This attempts to create a unique timbre for the sample that doesn't change throughout the melody. The last component I'll cover is the 12-data Java client, which I defined using the retrofit library for converting API endpoints to methods and responses to objects. There are essentially two implemented methods, fetch time series and symbol lookup. For fetch time series, you specify the security symbol and the trade bar width being one of these strings defined in the 12-data interface.barInterval class. You then also specify either start and end date times, or the end and the number of desired bars depending on the chosen method signature. The result of this method is an instance of the 12-data interface.timeSeries class, which has metadata and a values list of trade bars if successful. For the symbol lookup method, you specify a complete or partial symbol string and the max number of matches, and the return is a 12-data interface security set, having a data list of specified securities if successful. To extend 12-data client, you can refer to the 12-data API docs and study the endpoints and arguments for each endpoint. Then create a call definition with endpoint and arguments and classes to which the JSON response will be converted, with matching member names and structure. Note that the 12-data client is a separate repository, and Marketsense includes a specific version of it as a dependency, so 12-data client can be developed for use beyond that which Marketsense uses. The same goes for my rudimentary temp.fx logger project. That concludes my tour of an early version of Marketsense, both from a user perspective and from a developer perspective. Check it out and feel free to post any questions or suggestions to the GitHub issues section.